Hello! Welcome to this video on cognition. Here we'll emphasize two aspects of cognition: decision-making and problem-solving. Let's begin by considering decision-making, and importantly, some influences on decision-making. For many years, psychologists have known that framing affects decision-making. We can define framing in the following way: a cognitive bias in which people react differently to a particular choice depending on whether it is presented as a loss or as a gain. And a classic example of this came from Tversky and Kahneman in a 1981 research paper where they posed something akin to the following. In their dilemma, they asked the participants to consider a horrible situation in which 600 people were at risk of dying. After presenting that dilemma, the participants were presented with some different kinds of choices. In one version of this study, the participants were presented with a positively framed option. We'll call that option A here. In this case, the participants could choose option A as one potential remedy to this dilemma, and it was guaranteed to save 200 lives of the 600. In a different version of the same dilemma, still 600 people were at risk, but now the option presented to a different set of participants was framed negatively. Here we were specifying the loss. In particular, we specified that 400 people would die of the 600. Two things are very interesting to note. First, many fewer people opted for choice B, stated here in the negative, than for choice A, stated here in the positive. There was a tremendous bias toward the positive framing and away from the negative framing. Second, you might notice that the two options are mathematically identical to each other. That is, in the one case, you would save 200 of the 600 lives. Stated differently, you'd save 200 and lose 400. Here in option B, we directly stated that we'd lose the 400, but that would imply that you're saving 200. So in either case, we're saving 200, we're losing 400. But by positively framing the option, Tversky and Kahneman showed a tremendous bias toward the positive frame and away from the negative frame. It's interesting to muse about why that positive framing effect might arise. And one of the ways of thinking about this is to consider the phenomena of loss aversion, which we might define as the tendency to strongly prefer avoiding losses to acquiring gains. Psychologists have shown that decision makers often weigh losses more heavily than gains. So here's a way of thinking about this. Informally, the loss of, say, $500 generates a bigger change in subjective well-being, that is, psychological well-being, than does a gain of $500. Here again, as in the earlier example, we hold the actual change identical, 500 up or 500 down. Yet most people would subjectively report that the loss of $500 is a greater change in their well-being than is a gain of $500. And it's interesting to muse about this within the context of something we've considered before. Specifically, we might think about how loss aversion might have arisen in a universe characterized by the law of entropy, which is also known as the second law of thermodynamics. You may recall our earlier discussions on this in a prior video, and if not, you might choose to remind yourself about the law of entropy, or the second law of thermodynamics, by visiting this wiki. Okay, let's move on away from decision-making and toward problem-solving. Psychologists who study problem-solving typically distinguish between ill-defined problems and well-defined problems. Let's begin with understanding ill-defined problems, which we might describe in this way: a challenge in which the goal and/or intermediate steps are poorly specified. And here are some examples: publishing a research article in a prestigious journal, creating a computerized device, perhaps like an iPad or a cell phone or a smartphone of any variety, achieving peace in a conflict-ridden region, or responding effectively to natural disasters. What's interesting in each of these cases is that we have some idea about how we're supposed to act, yet we don't know exactly what the end state is going to look like, and we certainly have no idea about how to get there. So for example, let's take the first case of publishing a research article in a prestigious journal. Well, there are actually many different prestigious journals. Which one should we pick? What should the topic of our research article be? The instruction here does not specify. How long should the research article be? Well, the prompt doesn't tell us. This is an ill-defined problem. We can take other examples. Consider the case where we are tasked with responding effectively to natural disasters. Well, that can mean different things. That might mean, for example, minimizing the total amount of dollars that are lost in a natural disaster. It might mean optimizing the number of lives that are saved. It might mean something like restoring communication to the disaster-stricken area as quickly as possible. It might entail evacuating people from that area. There's nothing about this particular statement, responding effectively to natural disasters, that unambiguously specifies an answer to any of those many questions that we might have. So this is a less well-defined problem. We might call it an ill-defined problem. We can contrast this with well-defined problems. Here's one way of thinking about a well-defined problem. We can think of it as a challenge in which the goal and intermediate steps are clearly specified. And this is a really fun example. Here we have 9 dots, and our instruction is to link all 9 dots using 4 straight lines or fewer, without lifting the pen, and without tracing the same line more than once. We'll let you stop the video and try to solve this well-defined problem. Okay, why don't we move on and consider some obstacles to problem solving. One that is known well to psychologists is the idea of mental set, which we can define as the tendency to approach a problem in a particular way. And one type of mental set is known as functional fixedness. Can you say that with me? Functional fixedness. There you go. We can define that as a cognitive bias that limits a person to using an object only in the way it is traditionally used. So let's take an example of functional fixedness and see how psychologists might study this. In a classic study from the 1940s, participants were asked to attach a candle to a wall, and they were given a candle and a set of matches. They were also given a small box that contained tacks. Now notice that here the box is used to hold the tacks, and so if you were in this study as a participant, the first thing that you see is, yes, you have a box, but the box is functioning in a particular way. It's functioning to hold the tacks. One solution to this task is to get beyond the functional fixedness of thinking of this particular container as a container that holds tacks to a container that can hold the candle. And so what we might do is have a solution like this. We can now dump the tacks out of this box. We can somehow affix the candle to that box. Maybe we could melt some wax there, or we could stick one of the tacks underneath and get the candle to stand upright. And now this box, which was a tack holder, could now become a candle holder. And we could use one of the tacks to affix this to the wall. So now we have to think of this box in 2 different ways. It's not fixed to just hold a tack, but rather it could also hold a candle. Here's another example that might help you understand functional fixedness. Imagine that you are given some magic markers and you're asked to write down a few simple responses to some very simple questions on a piece of paper using the magic marker. At some later point, an experimental psychologist might ask you to solve some other kind of problem, but not tell you directly that you can use the magic marker. This problem might be solved, for example, by using the magic marker as if it were a roller. That is, you could put the cap on the magic marker, so you're not going to use it to write, which is what we usually do with magic markers. We usually write with magic markers. But here, you might put the magic marker down on the floor and use it to roll out some fairly heavy object. Now, the somewhat circular nature of the magic marker is being functionally used, and this isn't the way we normally think about magic markers, but you could use it as a rolling log. This would be an example of getting around functional fixedness, the idea that a magic marker is only used for writing. Okay, let's move on to a different kind of a problem and then see what other kind of strategy we might use to solve this problem. So here's an interesting problem that cognitive psychologists were asking participants back in the early 1980s. The participants were told about a medical problem in which a patient had a stomach cancer, and the stomach cancer could be cured by radiation. That is to say that we could send in some rays that would eliminate the tumor. The bad news is that if we wanted to eliminate the tumor, we had to hit it with a fairly high level of radiation, and in so doing, we would harm the surrounding tissue, which was, at this point in the patient's development, very healthy. So how do we go about getting that tumor with the radiation without harming the surrounding tissue? Very few participants were able to solve this problem. So let's consider what the participants were told in one version of this study. They were primed with a particular kind of solution that would work by analogy. And here's how the solution went. They were told about an ancient time in which there was an ancient military leader who wanted to overtake a castle, but could not get to the castle because the castle had been surrounded by a moat. One solution that had occurred to the military leader would be to build some kind of a bridge from his side of the moat across the moat so that they could move all of their horses and military equipment and overtake the castle. The problem is, as they began thinking about how to build that bridge, which might have been something as simple as several large boards across which all the equipment could move, they began to realize that there would be far too many soldiers and far too much equipment for any given board to hold. So another solution occurred to the military chief, and this solution entailed using several boards, one from this side, one from that side, one from that side, one from that side, and dividing the total amount of military apparatus that had to move across any one board into 4. This way, by lightening the load, they would not exceed the strength of any one board, and they could make it across to the castle and overtake the castle. So with that as a primer, some participants were then able to see that a way to answer the earlier problem would be to still stay with the radiation treatment, but now have relatively smaller rays of radiation penetrating from many different angles. They would converge onto the target tumor, and collectively they would be strong enough to get rid of the tumor, but individually they would be weak enough that they wouldn't harm the surrounding tissue. Once the people had been primed with this kind of solution, a much higher fraction of the participants were able to solve this problem. An intriguing note about this study was that the participants were only able to see the relevance of this analogy from the militaristic point of view to the medical point of view if they were told in advance that this story would somehow help them in solving the problem. If they weren't told that this story would help them, many fewer people were able to see that there were relevant similarities between the structure of this problem and the structure of this problem. So to summarize, we can say that one of the strategies for problem solving can be to find a relevant analogy and thinking about how you might apply it to the current problem. Thanks for listening.